This week we're talking about Blue Origin's NS-19. The original 6 went to space and came back. Solar wind may be spreading life around the universe. The Parker Solar Probe has touched our sun's corona. The Jame Webb Space Telescope is launching on Christmas. Let's do this thing. Thanks for joining us. Welcome to Today in Space, the All Things Space podcast. I am your space science podcast host from the East Coast, Alex Giafanos. A lot of words. It is the week of Christmas. We're recording this here on December 19th. It's our third episode of December. We should have one more out before the end of the year, including the Christmas morning launch of the Jame Webb Space Telescope. So I think coverage starts around 6:30 a.m. Eastern Time. They're launching from French Guiana on an Ariane 5. So around, I think it's 7:15, I believe. But regardless, it will be live on the broadcast, and we will be brewing up some coffee, and we'll be in some Christmas gear, and we're going to try to go live, obviously assuming everything still goes well. We are knocking on wood for the Jame Webb Space Telescope and all the teams and space programs. We've got ESA, we've got the Canadian Space Agency, we've got NASA involved in this, and it's going to be an astronomical wonder. It just has to get to space, so we're very excited for that. We'll talk a little bit more about what specifically Jame Webb Space Telescope is going to be able to do for us, and like how is that different from Hubble. So we'll close this week's episode out on that. To start, we'd like to join in to discuss Blue Origin. We've got to talk about that mission and our thoughts about that. We've got the Parker Solar Probe, which just touched the corona, launched in 2018. We talked about it here in the podcast. We're going to talk about what it did there. And then there's a research paper that we came across that is a really interesting hypothesis and basis for how solar wind might be wetting objects across the solar system, one of the original Hayabusa missions. So we will just talk about all of that in just a second here. Before we start, we just want to say thank you to everyone who listens to this podcast, subscribes, shares this podcast with others, tells people about what we're doing here, and we really appreciate you. For some folks out there who follow along on Twitter, Today in Space Pod, or my Twitter at El Greco, ELGR, the number 3, CO. We were giving away some of Gary V's new books, 12 and a half, and we've got some of those going out to podcast listeners. So thank you guys for playing along, sharing what you thought about some. I think we did something about the planets, and we did something about why science is important to you. What does it tell us about the world around us? So thanks everyone for doing that. We've got those books shipping out. That's a really cool experience I'll talk more about on the podcast, what Gary Vee did with this book. It involves NFTs. It involves a lot of stuff for the upcoming future. So we're trying to stay just in that world a little bit so that we have at least something, we have an experience to discuss about it when it comes here on the podcast, because the way cryptocurrency and technology is moving, all of this stuff will move together with space as space progresses. At least that's our hypothesis here on the podcast, and so we want to stay at least conversational in the ideas. There's not enough time in the day, never mind our lives, to become experts in everything. But if we can find some people to talk about it, if I can share an experience, so that would be very interesting. I don't know if anyone's been following Gary V's V-Friends project, but there's Discord. I'm doing my research. I'm watching along, and with this book, there's an NFT that comes with this, the Book Games NFT. So part of the Book Games is to when you bought those copies, 12 copies I believe it was, to get an NFT, part of this first step is like give away the books and then give them away for free on social media. So pretty cool stuff. We're gonna talk more about like what we expect from 2022 and closing out the new year. We'll have that the week after Christmas. The week of New Year's, we'll have that episode. We'll maybe talk a little bit more about the balance, and definitely really hope that all you folks out there around the planet that are listening, it's a crazy thing to say, but it's true. Thank you guys for spending your time here on the podcast, and we wish you nothing but the best this year. I know everyone's going through something right now. The world is crazy. Our lives feel like they're 3 times the speed and rate. At least, but just be good to yourself. I mean, we're not recording video this week because it was just too much work. Life is very busy. You know, there's a lot of things going on, but you know, for me, this podcast is kind of like my own mental health break. It seems weird, but this podcast is huge in just helping me gather focus. And the 4 things that we wanted to focus on this week were, last week, Blue Origin launched NS-19, which was the 19th New Shepard mission. It was suborbital, as we've discussed before, right above the Kármán line, right at the edge of space, and that was December 11th. It was originally scheduled for December 9th. It got delayed, but the crew of 6 included Laura Shepard Churchley, daughter of the first U.S. astronaut, Alan Shepard, and Michael Strahan, Hall of Famer, New York Giants defensive end. You had, he's obviously co-anchor of Good Morning America. Dylan Taylor, these are the paying passengers. Dylan Taylor, investor Evan Dick, Lane Ventures founder Lane Bess, and his child Cameron. And Cameron Bess became the youngest American, the first pansexual person, as well as the first furry to fly in space. I did not know that. Interesting. This is Wikipedia, so go figure. But hey, there's a first for everything. So NS-19, the mission patch was featured the initials of Glenn DeVries, who died in a plane crash a month after flying on Blue Origin's NS-18 with William Shatner. This mission was in honor of his memory. There's been a lot of I've caught myself getting really involved into these missions. It's sad that there's loss of life, but I really had a good morning watching this mission. We were on Twitter, sharing what we were seeing, and it was nice. It was a really nice mission. It was cool to see Blue Origin go out there with their Rivian trucks. You know, I like that both Blue Origin and SpaceX, they both have electric cars involved at some point of the human aspect, whether it's recovery in the case of Blue Origin or going to the launch pad like it is for SpaceX. So, very interesting mission. With 6 people on board that capsule, the New Shepard capsule, I don't know if there's enough room for how much room you would want to be able to look out all those windows and float around in space. I mean, you only have a short amount of time actually at 0G and at those heights and views. That 6 people, I don't know, man. That just feels like not enough room at all. We saw how tight it was with just 4 people. You know, I think back to Wally Funk. Wally Funk, I've had people send me these articles talking about this too whenever we talk about Blue Origin. That Wally Funk said that, you know, there's not enough room up there. She wants to be able to really enjoy 0G. And I couldn't agree. I mean, I think it's just a limitation of where they are today. With Blue Origin's orbital reef, that could be a very interesting... They could do some really interesting stuff for your experience in 0G. Let's see what they do here in the future. But I'm looking forward to more of these New Shepard missions. It'll be interesting to see who else they bring on board. But it was really good to see Michael Strahan on there. There was a really good moment after everyone came back. There were some good discussions. And, you know, Laura Shepard Churchley, like her, hearing her talk with Michael Strahan about everything, it was so cool. and even what she was talking to with Jeff Bezos. So there's a lot of really magical moments happening here with human space flight. It's really nice to see. Moving on, let's talk a little bit about our sun. Our sun is so focal in life as it exists. It really is kind of a miracle that we live in this moment of time in our solar system's development where we have the planets that have pretty much carved out great clean orbits for this planet, and we have Jupiter that's constantly shielding us and the inner planets from things coming outside of our solar system, and it's just amazing that we have life on this planet as we do. As crazy as it is here, it's amazing that we even have life at all. And one of these articles came up on my feed that was saying that solar wind and space dust may explain the presence of much of Earth's water. And so it's this research paper. It's an international team of researchers. They studied the dust from an ancient asteroid and found that the solar wind, which is charged hydrogen particles streaming out of the sun, could have combined with the space dust on this asteroid to create water, have a reaction, hydrogen combining with something that has oxygen, and then creating H2O, which on that asteroid, which then would have traveled to Earth, giving the initial amounts of water in that initial formation 4.6 billion years ago. So what they were saying, and this article quotes it, I'll go to the study in just a second. We'll read the abstract. But, sorry, drink of water. Our results suggest that somewhere between 50 and 75% by mass of the water on Earth needs to come from solar wind water in order to match or reproduce what we see in the Earth's oceans, said Hope Ishii, one of the authors of the paper. You can imagine that when you pour yourself a glass of water, about half of that is actually coming from sun plus rock. So this study took, they researched the samples from the asteroid called Itokawa, was collected by the Japanese space probe Hayabusa in 2010. They used high-tech imaging system called atom probe tomography to take a detailed look inside the asteroid dust, measuring the atomic structure one atom at a time. In these dust grains, they found a significant amount of water. And this is from an article in CBC Radio, Quarks and Quarks. The author is Jatinder Atwal. But so if you go to the research in Nature Astronomy, the abstract, the title of the paper is Solar Wind Contributions to Earth's Oceans. The abstract states, the isotropic composition of water in Earth's oceans is challenging to recreate using a plausible mixture of known extraterrestrial sources, such as asteroids. An additional isotopically light reservoir is required. The sun's solar wind could provide an answer to balance Earth's water budget. We used atom probe tomography to directly observe an average 1 mole percent enrichment in water and hydroxyls in the solar wind irradiated rim of an olivine grain from the S-type asteroid Itokawa. We also experimentally confirmed that H plus irradiation of silicate mineral surfaces produces water molecules. So that interaction of the positive hydrogen atom hitting the regolith, the soil of the asteroid, this silicate mineral surface, these results suggest that Itokawa regolith could contain 20 moles to the third. Wow, I don't know what that is. My chemistry, folks. Just because I'm an aerospace engineer does not mean that I know chemistry. But they're saying there is this amount of solar wind-derived water, a measurable amount, and that such water reservoirs are probably ubiquitous on airless worlds throughout our galaxy. So basically, there are potentially, if it's found on this one asteroid, Itokawa's regolith, then there's these other water reservoirs that have happened from them being exposed to solar wind, that when there's no air, this reaction can happen, and throughout the galaxy, there are all these things containing water. And the production of this isotopically light water reservoir by solar wind implantation into fine-grained silicates may have been a particularly important process in the early solar system, potentially providing a means to recreate Earth's current water isotope ratios. So, really interesting stuff to think how much life comes from the sun and a solar system, and the conditions that need to be there for the actual life to occur, for the chance for one of these asteroids, one of these bodies that has water that's reacted from this silicate mineral on the surface. The solar wind hits it, chemical reaction happens, and then you make and produce water molecules. It happens to hit a planet in the middle of its development, and then somehow, like our planet, you can make up the difference of how much water there would have needed to be where it didn't like dry up or disappear, or wasn't able to handle the harsh conditions. So all of these things may be necessary if we're going to look for life in another place. And figuring all this stuff up, learning about the sun and our sun and the conditions that our solar system has to make life is important for us to search for life like us, right? And the Parker Solar Probe is a mission, bringing it all back around. The Parker Solar Probe is a mission launched in 2018 that was sent to help us understand better the sun. Go and touch the sun's corona, basically the upper atmosphere of the sun, where you are literally touching the sun. So the Parker Solar Probe did that in August of 2021, earlier this year, and it's huge in many different ways. It's amazing that we're able to build a spacecraft with a sun shield that can get this close to the sun and still be able to send back images and a video of what it's doing, never mind the data that it's gathering on board. And this gives us a much better, like if we're talking about the health of our sun and our solar system, these early readings, this is really important to understand, to start tracking the cycles of the sun at this early, this closer, as close literally as any other spacecraft has ever gotten before. So the Parker Solar Probe there's this thing that it's discovered in 2019. It's something called these striking magnetic zigzag structures in the solar wind. So like the solar wind, as it comes out, it does this little like Harry Potter bolt movement called switchbacks, and it seems like they happen a lot, and it seems like they increase as you start to reach the corona. And so in August it finally got there. They weren't sure exactly where it was. This has been like predicted that this did exist, and now the Parker Solar Probe lets us actually test that, and they found it. So that's pretty amazing. We're going to learn more about it, what's going on there. It looked really chaotic. We posted a reel of the actual footage that came back from the Parker Solar Probe, and it looks like you definitely would not want to be there. You're just seeing what looks like particles and plasma shooting out, literally seeing the wind of the sun, and through whatever filter of information that they had, it looked like it was just video. You could see the Milky Way as it was turning, as it was going farther out in its orbit after the flyby. There's a lot of really fascinating stuff going on. I know we said that a lot this week. That's kind of my line. But this was a really cool week for sun research. There's a lot that we're doing, and it's cool to see these missions that we talked about years ago finally get to the point in their scientific progress where we get to then come back to it and say, oh, what are we learning this time? And this is the first stage. The spacecraft is really where it's supposed to be. And the Jame Webb Space Telescope is encapsulated. Wow, this is the second episode I've had a timer go off. That's that is me doing some behavioral techniques to help with dopamine release and moderation to counteract my attention with ADHD. So I need to do better about not doing this when a timer is going to go off. But when you hear those, that's exactly what that is. 20 minutes has been really good, but like 40 minutes also works pretty well. And that's the amount of time I'll set myself to do a single thing, and then I move on to the next thing in the next 20 minutes. It's been really nice. I've definitely noticed that it's made a nice positive difference. So more things that I'm going to be learning and sharing as anecdotal for what's working for me, as more as just a, hey, if there's a lot of cool stuff out there. I'm obviously, the Huberman Lab podcast is where I'm getting most of this info. I guess that's what I wanted to share. Is you should not be really taking the information from me, just knowing that the information I got from the Huberman Lab podcast, I've been applying it, and it's been working. So that's just pretty cool. When you just get to use scientific information and you test it, and I live for this shit. So the James Webb Space Telescope is loaded and ready to launch December 24th from the French Guiana aboard an Ariane 5. It's I'm saying a lot this episode. I apologize. Like I said, it's been a very long week. But the James Webb Space Telescope is going to unlock a whole new perspective of our understanding of where we came from. So, for those that may not know, the farther that you look into space, you're looking back in time, because the thing that you're looking at, the light that you're seeing from that object, had to travel a certain distance, light years, right? And how many light years it took for that light to get to you, to your eyes, is like, that's not what it is where it is currently, right? You're looking at what it was. And so it's at a totally different place. And so we were able to, with the Hubble Space Telescope, look back to a really great distance, to some early first galaxies, right? We got a glimpse with Chandra Deep Field of the first galaxies, the age of the universe, really, really long time ago, 1 billion years to 0.3 billion years, 400,000 years, is what is the cosmic microwave background. And James Webb Space Telescope hopes to bring us to see whether the first stars were formed. So then we get to trace the evolution of galaxy formation, an even better look at, all the metaphorical dice were rolled after the Dark Age and after the Big Bang. How did it all settle? How did it all develop? And then we can take those predictions of those things that we see and look at different areas of the universe to see where else life like us might be, or look for other specific things. Maybe there's other galaxies that we want to research. We'll have a better idea of where to look. We'll be able to study star and planetary system formation. We'll be able to characterize exoplanetary systems and look for possible signs of life, and observe, like we said, some of the earliest stars that formed right after the Big Bang, right after things cooled, after the massive inflation and expansion of the universe. And then how did things settle? That's what we're going to see the very beginnings of. And that is a huge jump in what Hubble Space Telescope and Chandra have already shown us. So it's a very big launch. It's going to be a very big day. Christmas Eve, December 24th in the morning. Look out for us. We'll be trying to go live on our Facebook page, Today in Space Podcast. My voice is going, folks. I think that's the end of this podcast. Thanks for joining us. Thanks for always hanging in there with us and sharing the episodes and letting us know what you like. Following us on Instagram. We have a lot of fun with you guys there. On Twitter as well. Space Twitter is one of the more enjoyable things, probably one of the only enjoyable things that I like about Twitter. And That's a lot of fun there, and I hope that you take care of yourself. Take a few moments to just, I don't know, de-stress or do something. I'm trying to do that myself. I'm very bad at that. That's part of the reason why I'm saying it out loud. But also, hey, be good to yourself. You're a human being. You're alive on this planet, this crazy rock flying through the universe. You're here, so be good to yourself. You made it. You're on this rock. It's a crazy ride, but we're here. So thanks for joining us. Have a great holiday. We'll see if you want for one more episode before the end of the year. Spread love, spread science. Live long and prosper. See you later.